My name is Jerry Haskins. I'm the Director of Software Lifecycle Engineering. I've been working with Unix for over 25 years now. I've been working with patching and Solaris maintenance for the last 15 years. You may know my blog, which is blogs.oracle.com/patch, the Patch Corner blog. And now transitioning to Solaris 11 and IPS and all the fun with SRUs and repos and the intricacies of the package command. It does make toast, I just haven't found the option yet. With me is Pete Dennis. Pete stood up. Pete is the tech lead for Solaris 11 SRUs to support repository updates. Pete's, if you've got any hairy IPS related questions, Pete, I will defer to Pete because he's the one I keep pestering when I can't figure out what the option is. Just my forward-looking statement, don't believe a word I say, especially anything that has will or future in it. The stuff I want to cover today, basically just a very quick overview of IPS. How many folks are already working with Solaris 11 or IPS, or few? Okay, so it's not completely foreign. And then, just a look at the Solaris maintenance overview. How many folks work with Solaris 10? Okay, good, excellent. Because part of the plan is, here's how we did it in Solaris 10, here's how we're doing it in Solaris 11, spot the difference, contrast, and compare. So if you didn't know Solaris 10, then I was on a loser. Also going to talk about the Solaris 11 maintenance policies and strategies and so on, and then obviously Q&A. I also have some nerdy stuff in the appendix, which I extracted from Pete in the last couple of weeks, and if you want, we can go through it. If not, it'll be in the slide deck, and you can look at it later. Some of the hokey-pokey IPS commands. So before we get started, I mean, the consistent theme through this, I joined Sun 15 years ago, and I was actually hired to be a development manager. And in typical Sun fashion, the first day I arrived, I said, "Oh, somebody else took that job. You're in charge of patch testing." Oh, okay. So I thought, well, I'll spend 6 months doing patch testing, hone all I've learned on my management courses, and then I'll go and find something more interesting. That was 15 years ago, and found out patches are actually interesting in a sort of train spotting type sense of stuff, and there was a lot of work to be done on it, and there still is. And a lot of the stuff that we've done on Solaris 11 and with IPS is basically based on the lessons learned with Solaris 2.6, 7, 8, 9, and 10, and the old SVO4 patch architecture and the deficiencies of it and so on. And in particular, in Solaris 10, if you look, I go back to Solaris 2.6 days, and in those days, the Solaris updates really were just new drivers and very minor features and really bug fixes. In Solaris 10, we started putting some huge features into the update releases. New boot, change the boot architecture and update release. ZFS, secure by default, trusted extensions, OPL. Those were huge features. And the old patch architecture really couldn't cope. And if you remember in the early days, the first few years of Solaris 10, trying to get a good kernel patch out the door became quite an art form. We had a lot of broken kernel patches that we couldn't release, and that was due to interactions with the features. And two of the key Solaris architects, Bart Smulders and David Comey, spent a lot of time with me to really understand the root causes of the issues and why this was difficult. And a lot of those lessons learned have gone into the architecture of IPS and have gone into what we're doing in Solaris 11. The other key lesson, for over 10 years, we used to produce 4,500 patches a year. Now that was Spark and x86, Solaris cluster, Solaris 2.8, Solaris 8, 9, 10, and so on. But that's a lot of patches. I'm trying to figure out which patches to apply to your system. So one of the most common questions I get asked is, just tell me which patches to apply. And so we did a lot of work on things like the recommended patch set and really trying to get the recommended patch set to do 95% right in 95% of cases, and then it's just the odd little corner cases that are specific to your environment. But really a lot of the team that goes through this is the KISS principle, is simplification. And my management Bible is the Dilbert principle. And Dilbert's definition of engineers is that most people believe if it ain't broke, don't fix it. Engineers believe if it ain't broke, it doesn't have enough features yet. And that was Sun's motto. That was certainly Sun's engineering motto. And as you know, there's probably 20 different ways to do anything you want to do in Solaris. What we're trying to do here is sort of learn, by the way, Dilbert's definition of marketing is also good, a combination of alcohol and guesswork, which I think is pretty appropriate. Is that familiar? Anyway, so again, what we're trying to do here, a lot of this is the KISS principle. Now, last year, not just in one go, but last year, Pete and I presented the original version of this slide deck at OpenStore. And that was sort of looking forward. Here's how we intend to maintain Solaris 11. A year later, in a year of experience, here's how we are doing it. And it is subtly different. Again, simplified. And this is the first time I've presented this. So I am very interested in your feedback. Is this on the right track? Is this totally wrong? Have we oversimplified it? Do you like 4,500 patches? Do you want us to bring that back? You tell me. So anyway, moving on. So IPS, so image packaging system, is used in Solaris 11. It's also used in cluster 4.0 or 4.x. Single tier packaging architecture. So no more 2 layers, 2-tiered System 5 Release 4 packaging and patching, where we have a package architecture and then a patch architecture, patch utilities and package utilities and so on. And as I said, the architect spent a lot of time with me understanding some of the issues here. So in patching, you could have pre-patch, post-patch scripts. Now those were free-form scripts. They could do anything you like. And from a test perspective, pretty much impossible to assure that they could work in every single install environment, whether it's mini root or diskless client or whatever oddball install environment it might be. And also, if ever you've by hand tried to recurse patch dependencies, it really is for the masochistical. With IPS, Solaris 11, as you probably know, only supports ZFS root. And the reason for that is then we can leverage things like the ZFS snapshots, and we get free alternative boot environments pretty much for free with very little overhead with BE-ADM. And if you don't know BE-ADM, it's sort of live upgrade on steroids, much better, much slicker, much more integrated, much more supported, much more integral to the system. Packages downloaded from a repository. We also provide ISO images, I did spell that right, on MOS. Many customers will typically, set up a repository behind their firewall, which they will maintain at the levels they want it to maintain. They can download the ISOs and then add them to that internal repository. The IPS packages are fat, so it's the same package that contains both the Spark and x86 downloads, simplified Chinese locale, C locale, whatever else you're having. And IPS is intelligent enough just to download the bits that are needed for the system in question. Any questions on basic IPS? So let's look at the maintenance overview here. Typically, there's 2 main types of maintenance, as you know. There's proactive maintenance and then reactive maintenance. Proactive maintenance, where you've got some chance to plan in advance, maybe do some testing if you've got homegrown or third-party apps or third-party hardware or storage or whatever else. And to check out for configuration specific issues. The major proactive maintenance updates, where you might be updating the OS, maybe moving to Solaris 11 or Solaris update or 11G or 2, frequently is associated with hardware rollouts. But then we also have minor patching proactive maintenance windows, just getting the latest bug fixes, maybe security, or just applying an SRU or the recommended patch set. And then we have the reactive case, where there's very little time, there's very little chance to do pre-deployment testing. Something's broken, need a fix straight away. or there's a policy the security fixes must be applied within a week of release or something horrible like that. In Solaris, always, at least going back 15 years, all changes are made to the tip of the source tree. So there's basically a single source principle. It's the same source for Spark and x86, and all changes, whether it's a bug fix or a feature, goes into the tip of the source tree. So that means everything is cumulative. It's not a multi-branch system like, for example, 11G2. It's a single source, single tree. And one of the principles of that is it means that the more frequent the proactive maintenance, then when you have a reactive situation and you need to take a fix, the smaller the change delta is because the closer you are to the tip of the tree. And that's something, I don't mean sort of dawned on me to actually put that in a slide deck last year, but it is quite an important point. Solaris updates, we've always typically updated once or twice a year. They'd have hardware support, software enhancements, new features in it, as well as all of the bug fixes that are available. Now that's all accumulated bug fixes. Also, if a bug fix that a customer reports is considered relatively risky, the fix is relatively risky, we may put it into the next update release rather than release it in the sustained train straight away, because we want to get more test time on it, we want to get more making sure there's no regressions in there. Normal customer reported bugs will be fixed in between the update releases. In Solaris 10, that was via patches, and Solaris 11 is via the monthly support repository updates. And then we also have interim diagnostics and relief, which is, as the name suggests, it's either getting the diagnostics to try and get to the bottom of some hard to debug issue, or providing the initial release candidate fix to verify, yep, this does actually fix an issue. In particular, if that's an issue which is a third-party interaction, let's say with Veritas or IBM PowerPath or Apache Storage or something like that, which may be difficult for us to reproduce in-house, that we can get some relief to the customer and verify that that actually is the proper fix before we put it out into the proper sustaining tail. So our development tree, as I said, it is a continuous development tree. I'm not sure how accurate this is, but anyway, we have the releases like Solaris 11, 11.0, and then we have the bug fix releases to that, whether it's patches or in this case it's Solaris 11 SRUs. And then we'll have an update release and bug fixes off that, an update release and bug fixes off that. Now, one thing that we are doing differently in Solaris 11, thanks to Pete, one of the problems we used to have, and one of the things that used to delay getting bug fixes to customers, was because we have a single source, the update release is a superset of all of the bug fixes going before it. And therefore, when we're trying to finalize the update release, get it ready for release, it goes into what we call stopper mode. So we'll only put in really critical fixes affecting that release. But because that's a superset of the sustaining tail, it means we can't put anything else in the sustaining tail. So we used to have a sort of 6 to 9 week hiatus where we really couldn't get normal bug fixes out to customers at the end of the update period. And that was a pain in the neck for everybody. So that really delayed bug fixes. What we've done in Solaris 11 is get rid of that hiatus period. So we will continue to deliver critical bug fixes to customers right up until the update releases. Now the consequence of that is the update is no longer a rigid superset of the preceding sustaining tail. It's a superset of about SRU minus 2 of the sustaining tail. All that means is that the upgrade path from the final SRUs like SRU 12 and SRU 13 will be to the first SRU after the update, because that will be the superset. Okay? Now IPS is intelligent enough that it will stop you shooting yourself in the foot and losing bug fixes. But this is, the only reason we're doing this is to get bug fixes out to customers faster and get rid of that update hiatus. So potentially slightly confusing, because always update releases have been a complete superset of everything that's preceded, and now it's the SRU after the update is the superset. So on this, basically, after the last SRU for 11.0,